Okay, this is another paper, the latest paper, May, June 2021, and the paper is 1-2. Move to question number 1. And the question is, what is not reasonable estimate of the physical quantity indicated? So first look A. 2 into 10 power 3 mean 2000 watt for the power dissipated by the heating element of the electric. Yes, it's possible. This is not the answer because we have to choose the wrong option. And then 4 into 10 power 2 mean 400 meter cube for the volume of the water in the swimming pool, but this is possible. So 5 into 10 power 5 mean 500,000 Newton second for the moment of the lorry moving along the road. Yes, it's possible. And this is 600 Newton for the weight. So 600 Newton mean 60 kg for a weight of the fully grown racehorse. So this is wrong. So the option is D. So this is incorrect estimation. Now the next is which quantity could have unit of Nm Newton meter per volt. Look, formula is voltage is equal to work done per unit charge. Work is FD divided by Q. So the Q can be written as FD divided by V. F is measured in Newton, distance in meter, and this voltage in volt. So charge is the option here, B. And the next question number 3. An object is acted upon by two forces, 10 Newton in the vertical direction of the 6 Newton at 40 degree to the vertical as shown, which is the resultant force acting on the object. So by drawing, we have to add these two. So look, this is 10 Newton. We have to add the 6 Newton in the same direction. This is the resultant. And then we have to calculate, we have to measure this angle. You have to draw it with a scale. First take the scale, 1 centimeter, 1 Newton, 10 centimeter long line. And then this angle is 40 degrees. So place here the protractor, draw here a 6 centimeter, then join this is the resultant, and then measure the angle this with the protractor. So you will get answer this one. But do it with a scale and protractor. Next, number 4, an analog meter with range of 0 to 250 milliampere is connected into electrical circuit. The diagram shows the ammeter display. So it means this 10 scale is representing 250. And actually, this pointer is at, this is 6, 7, 8, and this is 7.2, 7.4, 7.6. So 7.6 will represent how much this by unitary method. So by calculating the answer, you will get the correct answer, and that answer is approximately this D. So look, 10 scale is representing 250 milliampere, and the pointer is showing the 7.6. So 7.6 for this. So we will write this 250 divided by 10 multiplied by 7.6, then you will get the answer. Now the question number 5 is a very easy question. Student takes reading of the volume of the liquid using 3 different pieces of the measuring equipment X, Y, Z. The true value of the volume of the liquid is V. The student results are shown. How many pieces of equipment are precise and how many accurate? Okay. The reading is accurate if the peak is formed exactly at the true value, so 1 and 2. And the precision if the peak is sharp, so again 1 and 2. So the answer will be D. And in this question, question number 6, which graph shows the variation with time t of the velocity of the object falling vertically downward in a vacuum? So acceleration is constant. There is no air resistance, only the weight. So acceleration is constant. So the constant acceleration is this. This is deceleration, retardation. So this D is the option. And the next, a projectile is fired from the point P with a velocity v at the angle theta to the horizontal. It lands at the point Q. Horizontal distance r from P, air resistance negligible, acceleration of this. So we have to derive the expression for the range. Look, this velocity has two components. One is Vx, other is Vy. On reaching the top, this Vy becomes 0. So vertically, V is equal to U plus AT. So the final velocity, vertical, 0. And initial vertical velocity is Vy, mean V sine theta. And it's going up, so minus G into T. So V sine theta over G, this is the time to reach the top. And the total time taken from P to top and then top to Q will be the double of this. Now, the horizontal distance R is covered by the horizontal velocity. So we can write S is equal to UT, 1 by 2 AT square. The horizontal distance is R, and the horizontal velocity is Vx, and the total time taken is V sine theta over G times 2 plus 1 by 2. The horizontal component of the velocity will remain same. So there is no horizontal acceleration into T square. So R is equal to Vx in V cos theta into V sine theta divided by G times 2. So R is equal to 2 times V square sine theta cos theta over G. So B is the answer. Now move to this. This is a tricky question. A book of the weight W is at rest on a table. A student attempts the Newton's third law. Action and reaction equal in magnitude, opposite direction. So if the weight of the book is the action, so what is the action? Look, the action is W force is exerted by the earth on the book downwards. This is action. W weight is exerted by the earth on the book downward. So mean earth is attracting the object downward, the force which is called the weight. Now the reaction will be same W, and it will be from the book on the earth but upward. That's why the C is the answer. The force W, because action and reaction both are equal. Acting upward because the action is downward, on the earth from the book because the action is the force from the earth on the book, the reaction will be the force from the book on the earth. So C is the option. Next, number 9. 4 balls are dropped at the same time from the top of the tall tower. There is no wind blowing. No wind blowing mean still air. When the object falls, when the object moves, air resistance will be there. Which ball hits the ground first? Look, we have to compare air resistance, which is CRV, or it is 6 pi eta RV. And we have to compare the weight, which depends on the mass. So now this force, air resistance, depends on the radius, mean the diameter, and the weight depends on this. So for the large acceleration, weight must be greater than the air resistance. Object is falling down, weight is acting here, air resistance up. For the large acceleration, because which the ball will hit the ground first, which will have the large acceleration. So weight must be greater than this. So weight must be greater mean more mass is given 4m, and the smaller the diameter, smaller the radius. So the option is D. Option is B. And then question number 10. A nitrogen molecule P traveling at a speed of 320 meters per second in a vacuum collides with a stationary nitrogen molecule. After collision, P travels a velocity of 180 meters per second at the angle of 55 to the original path. Q travels in the direction at the angle of 34 to initial path. Assuming that there is no external force acting on the molecule, what is the magnitude V of the velocity V after this? So all are nitrogen molecules, both are nitrogen. So we will take same mass, suppose 1 unit. Now, this is linear momentum. Before interaction, momentum is linear and then becomes angular. So we will take one component, for example, the X component, because it's horizontally. So M1, U1 plus M2, U2, M1, V1, M2, V2. So we take horizontal component. So this is moving horizontally. Suppose its mass is 1, just assumption. Its velocity is 320 plus this is at rest. So whole momentum goes 0. And the P mass is this. And its horizontal velocity will be 180 times cos of 55 degree. And then plus this one. V, the mass is 1, velocity V, but its X component will be cos of 34 degree. So this is 320 is equal to 180 times cos 55 and plus V cos 34 degree. So we have to solve this. Okay, so this 320 and cos of 55 multiplied by 180 is coming 103.2, and then cos 35, this is 0.83. Now we have to subtract this 103.2 from this 320. So 320 minus 103.2 and divided by this. So the final calculation, the answer is 261. So close to this, 260. So just one component, X component. Next, the question is, a charged particle is placed in a uniform field of the force. The direction of the force on the particle is opposite to the direction of the field. Look, if the field is gravitational, then the force on the object is downward. So this is not the gravitational field. Now the second option, electric. If the field is electric, then this side positive, this side negative. When we will place here the negatively charged particle, it is attracted up, yes. So the negative charge particle will experience force in the opposite direction to the direction of the field. So the answer is A. And the next is simple one. A disk of the radius r is acted upon by the two opposite forces, each magnitude f. The force from the couple as shown. What is the torque of the couple? Look, both forces are making the couple. Its turning effect, its torque is Fr, and this is also R. So it's Fr, both are trying to retain the same direction. So Fr plus Fr, it becomes 2Fr. So C is the option. And the next is a uniform square sign of the weight 40 Newton is suspended vertically from the top edge by the horizontal hinge. The hinge is not frictionless when the sign is displaced from the vertical by the external force. It then release, it does not return to the original position. The maximum torque exerted by the torque on the hinge is 6. The sign is displayed by the 90 degrees, so that's horizontal and then gradually released. At which angle to the vertical does the sign hangs after the release? Okay, the turning effect is given. The torque is given, and it is 6. But this is equal to FD. But we have to calculate the angle. So FD sine theta, because this 6 torque, Newton meter torque, is balanced by the rotating torque. Now, we can write formula. Torque is equal to FD sine theta. Now substitute the values. So this is 6. And the force is actually the weight of this, which will bring the whole sign back. That is a 40 Newton. And its distance from the pivot is the half of this 0.8. So it's 0.4 and multiply by sine theta. I mean, actually, we have to calculate the theta. So 6 divided by 40 divided by 0.4, and its sine inverse is the theta. Let me calculate. Okay, after calculation, the answer is coming 21 point something. So sine inverse 6 divided by 40 times 0.4 theta. So answer is coming this 22. Now the next is each foot of the elephant has a circular cross-sectional area of the circumference 1.4. The elephant has a mass of 5,400 kilogram. The elephant is standing still with all 4 feet on the ground, assuming the pressure under each foot is the same. What is the approximate pressure? So look, the pressure is equal to force divided by area. Now, on 1 foot, the force is exerted equal to 1/4 of the weight. So 1 by 4 multiplied by mg. So 5,400 times 9.81 are just 10 divided by area. Now for the area, look, the circumference is equal to 2 pi r. And it is 1.4. So 2 pi r. So we can calculate the radius. So the radius is equal to 1.4 divided by 2 pi. And then area is equal to pi r square. And it is 1.4 divided by 2 pi whole square. So after the calculation, okay, so the answer is coming 85,000 Pascal. So 85,000, so C is the answer. Now the next, a stone is falling vertically through the air at the constant terminal velocity. Which energy change is occurring? So when the constant velocity, there's no change in kinetic energy, the kinetic energy will remain same. So the gravitational potential energy is decreasing and it is converting whole in thermal energy, the heat energy, because no change in the kinetic energy. So answer A. Kinetic energy is not changing because it is falling with the terminal velocity. Now the next, number 16, is an object of the weight 12 Newton rests on the platform on top of the container with the 2 pistons, as shown. The container contains a fixed mass of the gas. As the pistons are free to move, the plunger is slowly pushed 4 meters to the right. As a result, the object slowly moves upward a distance of 0.5. How much work is done? So the work is equal to force into distance. and the weight of the object is 12. It means 12 Newton forces applied, and the distance covered by this upward is 0.5. So multiply by 0.5. So the answer will be 12 multiplied by 0.5. So this 0.5 is centimeters. So we have to divide it by 100 because this is centimeter. So the answer is coming A. Next. Look at this question. The question is a constant force F acting on the car of the mass M moves the car up the slope through the distance at the constant velocity V. The angle of the slope to the horizontal is alpha. The acceleration of G of the free fall is Z. What's the ratio? Gravitational potential energy of the car and the work done. Look, the work done is F into S. And the potential energy gained here is mgh. But the h is this vertical height, this one. So in this triangle, this height is the perpendicular of the triangle and S is the hypotenuse of the triangle. So we can write h divided by S is equal to sine theta, means sine alpha. So the h is equal to S sine alpha. So here, mgh mean mgs sine alpha divided by the work done is F into S. So when S is cancelled, so mg sine theta over F. So this is the answer D. Next, 18. What is the definition of the power? The only definition is work done per unit time, rate of doing work. So the answer is D. Next, a steel bar of the circular cross-sectional area is under tension T as shown. The diameter of the wide portion of the is double than the diameter of the narrow. What is the value of the stress? Look, stress is equal to force divided by area. So we can write F divided by area of the wide portion, F divided by area of the narrow portion. So it can be written as then F divided by A of wide multiplied by area of narrow divided by F. So the F is cancelled. Now the area is equal to pi by 4 diameter square. So the diameter of the narrow square divided by pi by 4 of the diameter of the wide square. Again, pi by 4 cancelled. Now the wide area is double of that. So we can write here. So D square for the narrow divided by 2D for the wide square. So it is D square divided by 4D square. So again, D square cancelled. So it becomes 1 by 4. So the 1 by 4 is 0.25. So answer is A. And the next question is, two guitars strings are stretched by a tensile force. String X is stretched by the tensile force F that causes an extension X. String Y is stretched by the tensile force 2F that causes extension 2X. The string obeys Hooke's law. What is the ratio? Strain energy in X divided by strain energy. So simple formula, 1 by 2 Fx divided by 1 by 2 2F and 2X. So when we will cancel, 1 by 2 cancelled, F cancelled, and X cancelled. So we are left with 1 by 2, 2 into 2, 1 by 4. So the answer is D. Okay, so the first 20 question done. Now the second 20 questions being 21 to 40 question in the next video. Okay.